Hello everyone, welcome back to the tutorial. And here we are going to take in this session the concept of something called as lambda functions. So I think previously we have seen an example, right? We tried the addition function into that two parameters were being there. And we were simply returning something that is the addition of two numbers a and b. Fair enough for all of you. To see for one thing, these functions are simply one line and writing an entire body of function, defining it with the help of def keyword, followed by naming it and accepting the parameters is an overkill. Okay. For a single line function, right? Whatever you want to execute, writing a big body alongside def keyword, addition name, and all these things, simply they are kind of a killer one. So one thing is that without defining a complete function, can I try to replace it with simply a single liner? Is that possible? So lambda functions allow us to do that. Let's see how it does. And basically, what is the respective syntax of writing lambda functions? To see for one thing, in order to define a single line function as a lambda function, what we are required to do? We are required to first give the respective keyword as lambda, correct? And afterwards, once you have defined the lambda keyword, you are required to mention what are your respective parameters. So I can name the variables a and b. What is the return value we are required to deal with? So it's gonna be the respective value of addition of two numbers a and b. Correct enough? So yeah, we are done with our entire function. Correct? That's how basically this entire function can be replaced with a single liner function, what we call as the lambda function. Now, how you are going to call it? First of all, whatever is the specific lambda method, I'm required to take the help of a variable in order to call it. Fair enough? So let me say that lambda method is being referenced by the addition variable. And if I wish to call it, how to do that? Straight away within the print method, call on for the addition lambda method, and into that pass on the respective values of parameters a and b. Correct? So once I've done that, right, what's the result we are going to get? Let's see. So the behavior is quite same as that of our respective normal functions. Correct enough for all, but it's that if you are having just a single line to be executed within a function, entire method definition is not required. Single liner lambda methods are sufficient in these cases. Whenever there are more than one lines within a specific function, the overall logic is quite complex. Multiple if else within a function, you are writing loops, then such kind of methods cannot be replaced with lambda functions. Lambda functions have a limitation, right? What is it? They are strictly one-liner. If the respective function have one line to execute, then only lambda methods come into the play, correct? You are required to have something called as the return keyword, right? Into normal functions. Inside lambda methods, this return keyword is not required. It is quite implicit that whatever is the result you are aiming after the colon sign, right? This would be automatically returned. That's how it's presumed. Fair enough? So another thing is that inside a specific function, after the def keyword, you give that a name, correct? Lambda functions are anonymous. They are not named at all. But yes, these lambda methods are being referenced with the help of a variable. Without this variable, you may not be able to utilize the respective lambda method, whatever basically you have written. Fair enough? So these are a few contrasts we can try to have between normal methods and lambda methods. Correct enough? So in terms of methods, if I am saying, I'm referring to functions. Keep that within the mind. Fair enough for all of you. So let's take a few examples where our lambda functions can be very much useful, correct? So just like you are having simply, let's say, addition of two numbers, right? How about, say, a specific function is calculating the sum of a list? Then what? So in that case, function could have been, it is accepting a list L as a parameter. Whatever is my list sum, right? Let me reference whatever is my list sum, let me make that as a variable. And let me try to define a lambda function. It's going to be accepting a list L for us, right? And here, as per the given parameter, I would be calculating the respective sum of list, and that would be implicitly returned. No explicit return keyword is required as per the nature of lambda methods. Fair enough? So what I can try doing is straight away do one thing. Try to call on for the list sum method. And basically, this is the lambda function. And pass on within square brackets the respective list values. Fair enough. Try to execute. So yeah, one extra bracket we have missed. So yeah, I think the print definition is complete right now. So we can go ahead. So yes, I think right now we are able to get the entire sum of list quite well enough. Correct? So I think if sum of a list can be calculated like this, right? How about you go ahead and try yourself to print the maximum of a list utilizing Lambda methods? Not only maximum, as a part of your exercise, you can try with the help of Lambda functions printing the maximum, minimum, all of a list, let us suppose. Fair enough for all, right? So yes, if I try to twist the question a bit for you, how about you are trying to have the second maximum element of a list, right? With the help of Lambda function. What we can try doing then? So let me define a variable second max that is basically referencing to a Lambda method. It takes a list L. And what we are doing is, first of all, the list value can be anything. Okay. So I'm arranging that in ascending order. Fair enough. How we can do that? I can call on for a inbuilt method, what is sorted method for me, right? Taking the help of sorted method, I'm putting into that the list value. So what this method does is, it is basically arranging all the respective elements of the existing list, right, into the ascending order. And that ascending order list would be a newer list. Okay, basically a copy of the existing list. And that would be returned to me after calling on for the method here. Okay, once you have got on for that specific ascending order new list, it's minus second index value. Correct? So that should be ideally the second largest element of that list. And if I try to call on for the specific Lambda function with the help of second max variable, I pass on the specific list, right? It should be giving me the second highest value as 4. So let's try to run this, and the overall result corresponding to the list of 4, 5, 2, 3 is going to be 4 for us. I think that's fine. And this is the way basically how we can try to access second largest element of a list, right? Utilizing Lambda functions. Fair enough. What more applications we can try to have for Lambda functions? Let's see that. Now, suppose I'm having a list, right? And corresponding to that, the values, let that be 1, 3, 5, 7, whatever it may be. It can be anything. So the task associated with this list is you are required to convert every element of this list to its 2x format. That is, if the list is having the value 1, 3, 5, and 7, the final list should be having the respective values as 2, 6, 10, and 14. Every value has got multiplied with 2. Fair enough. That's the 2x format of each and every element. How you can do that, by the way? Transformation of each element if you want to do. I think previously we have utilized something. Remember the map functionality we have utilized while splitting of the values in the user-driven input session, whatever we have taken earlier. So just utilize that. Okay. How you can try to do it? First of all, write the map method, correct? Okay. And into the map method, as a part of my second parameter, I'm required to give the list. Fair enough. Okay. List elements are required to be transformed, correct? Now, who is going to do the transformation? It is going to be done with the help of a Lambda function. Fair enough for all. Let's try that. I would be writing a Lambda function, and x would be the respective parameter. Okay. And whenever we are having a value inside the x variable, we are going to convert that to its respective 2x format. Okay. That's how basically your Lambda function is going to work. Okay. So once your entire map function has ended, whatever are the contents that you are throwing out would be in the form of a map object. Okay. You are required to convert that to a list. Then only the list contents would be out for us. Correct enough? And that I can store that within my result variable. Okay. Post that, how about you try printing the respective result, right? What overall comes up? So let's execute. So we are able to see 2, 6, 10, and 14 are my respective resultant list. So let's, by the way, see how this Lambda function is making some meaning here, right? You might be a bit confused that what this syntax is all about. So this overall Lambda method takes into its second parameter the list, right? Whatever may be the list content, let that be 1, 3, 5, and 7, right? Each and every value, right, would be pointed by your parameter x one by one. Firstly, x would be pointing to 1. Then what the Lambda method is doing, once this Lambda method is receiving the current value of x, it returns the resultant value as 2x. That is going to be 2 multiplied with 1 in the first iteration. Then next, x receives the value as that of 3, the next available value of the list. And as per the Lambda function, whatever may be the current value of x, right, it would be converting that to 2x. So the conversion has got equal to that of 6, 2 multiplied with 3. Next, similarly, x would be pointing to 5, or 5 would be fed to the parameter x. And here, I guess value would be transformed as 2 multiplied with 5 equal to that of 10. Similarly, for 7, it would be converted to 14. Correct? All these individual values, by the way, 2, 6, 5, and it should be 7 here, right? It should have been 7 here, right? So it should be, I think, 2, 6, 10, and 14. Whatever are the individual values, they are a part of something called as the map object, correct? Now, if you convert that to the respective list, right, then these individual values take the form of a list. So that's how basically the conversion is going. Fair enough for all of you, right? Okay. Now, if I say that corresponding to a list, try to extract all the respective even numbers. How you can try to do that, right? So just like we have utilized something called as the map functionality, we have another functionality called as the filter functionality, right? Let me try to have a list, and that would be containing for us multiple kind of values. 1, 4, 10, 5, 9, and 6. Among them, you are required to do what? Extract all the even values, let's say. Even or odd. Let's try to have the even part. Correct? Again, I would be doing one thing. Perform the result calculation. The result has to be converted to a list, correct? And then here, I will be going ahead for the filter method, right? And what will happen is, into the filter method, the list L would be fed as a second parameter. Now you're required to do what? You are required to say that if lambda method is receiving the value of x, right? What I'm required to do is, first of all, I'm required to give a condition. If x mod 2 is equal to that of a 0, then feed that x as a part of your resultant final list, else don't do that. Correct? One by one, again, in the similar manner, all the values of the list would be fed to the parameter x, whatever may be the parameter x that has been received in the current lambda function, right? It would be checking whether the specific value is even or not. So what is the condition for that? X mod 2 is equal to that of 0. If this condition comes out to be true, right, this x will be part of the final result list. If it is not true, then definitely this would be discarded. This will not be a part of the final result list. Okay, keep that within the mind. So like this, we can try to perform some filtration as well. If I try to execute this and try to have my final result, then let's see what happens. Are we able to get the even values as 4, 10, and 6? Yes, right? So filter is a great way in order to filter out the elements from the existing structure to a different structure. Okay, and for that as well, lambda methods are the way to go because they do the actual filtration for us. Fair enough for everyone? Okay. Okay, now see that suppose you are having a word list. Let me just have that in terms of the words variable. And here, let us suppose you are having strings, right? Let's say that first of all, you are having apple, followed by kiwi, followed by, let's say, you are having coconut, and let there be orange as my last fruit, right? So that's how I have defined the words list. So your task is what? Sort these respective fruits, right, on the basis of their word length, right? So if I try to sort that, them, right, kiwi should be coming as the first element of my respective list, correct? Whichever would be having the shortest length, that would be placed first. Followed by, I guess, next apple should be the next element. Followed by, I guess, orange, right? 6-lettered string. And after that, we are going to get something called as coconut. Okay. So how we can try to do it, by the way, how we can sort this? Now sorting is the arrangement based on length of each string, correct? That's the sorting criteria for us. Okay. So we can try to have the result calculation. We can again utilize something called as the sorted function. Fair enough, all of you. Then what else we are required to do? I would be feeding into the sorted function the words list. Done. After that, here you are required to give a key parameter. So after this words list, right, we are mentioning something called as the key parameter. What is it all about? It is basically for the sake of comparison. Okay. How to compare two entities of the same list and which one to place first, which one to place at latter position. This is what key decides, correct? Okay. Now, what is that? If I mention that how key should be operating, it should be based on the respective lambda method. Fair enough? Okay. So I would be saying that lambda accepts a single parameter x and the comparison has to be based on the length of x. Each and every data of my words would be fed to the parameter x, and the decision to keep the respective x before or after based on the sorted method, right, That would be decided based on the length of the string, current string X, whatever basically you are keeping. Fair enough. So let's try that and see what the overall result comes out to be. So we are able to see right now, since length is the deciding factor, the kiwi fruit has appeared the leftmost, followed by apple, followed by orange, followed by coconut. Fair enough for everyone? Okay. So few examples corresponding to that of the lambda functions we have just seen, right? A few exercises that you may try is, suppose that you are being given a list of tuples, okay? And here let us suppose you are having data of different persons. Person A is having age of 26, let us suppose. Person B, let's say he is having an age of 25, followed by, let's say, person C is having an age of 16. You are required to arrange these individual tuples, right, as a sorted list. Sorting criteria would be based on the ages. The specific person who is having the smallest age should be, that tuple should be placed the leftmost, followed by the next greater age, followed by the last greater age, and so on. So this is the sample list I am providing. The main intent is you are going to take the respective tuples as a part of the list and sort them based on increasing order of the ages, right? So try to perform this activity with the help of Lambda methods. Fair enough, everyone? Based on the current examples, right? You can also try converting a specific list where each element would be converted to its respective squares. We have converted here to its 2x part, and your task would be to convert them into their squares. Fair enough? Try filtering the odd elements within a list, just like we have done here for the sake of even ones, and try playing around with some more examples of strings. Correct, all of you? So this is all about how we can utilize Lambda functions for a few use cases. Going forward, as the course progresses, we can see some more usage of Lambda functions where that can be utilized. So stay tuned. Thanks.